Hey, what's up? My name's Caleb King. I'm a software developer. And for this episode, I want to talk about 5 tips for reducing bugs in software development projects. Every software system has bugs. So why not just share some of the things that can really make your life a little bit easier? Now, if you don't know what I'm talking about when I'm talking about bugs refer to unexpected behavior in a software system, in an application. And we've all probably have experienced bugs. And there's different types of bugs. And they're, like my boy Meek Mill says, there's level to this. And when we're talking about bugs, you can have bugs where, hey, the text is off. Maybe, hey, like for some reason, when I enter my name, I can't see it after I type in so many letters. But then there's the really bad bugs. And it all depends on where you work. If you work at a bank, let's say you work at Wells Fargo, and people cannot log into their account, let's say longer than 24 hours, and it's not a holiday. And again, it's 2021, right? So you should always be able to log into your account unless they're down for maintenance for like an announced period of time. You guys get what I'm trying to say. Bugs are everywhere. And when you find bugs, it truly affects the software quality directly. However, on the other hand, software quality defines the future success of every software project. So it's like this yin and yang type thing. And the reason I want to do this episode is far too often, people just overlook very simple things that can make your life a lot easier. What's the worst thing about being a software developer that no one ever tells you or no one talks about is being on call. You can have the cars, you can have the house, you can have the wife, you can have the kids, you can have all of that. Software development can give you a skill where you can truly change your life, but no one ever talks about the hard part. And again, it's not hard compared to like people who are having to save lives, people who are out there doing more intense stuff than us being behind a screen. But what I'm trying to say, being on call is very stressful because depending on where you work, what you support, what you built, who uses it, the type of data that it holds. I've been on calls where I've got on call at 3 a.m. Caleb, the system is down. I don't care what you're doing. I need you to wake up, hop on this call, talk to 30 people who are also waking up, different time zones. And we need to figure out what's going on. Who did what happened, reverse it. Let's do a retrospective. Pretty much all of us come back, we review it, and we figure out what did we do, how can we make sure that never happens again. No one ever talks about being on call. A lot of times being on call happens because people introduce bugs. So let's talk about 5 tips that could really help you. Think twice before using a dependency. Programmers often use dependency libraries to save time, which makes sense. Why solve something that's already been solved? If you need to build a Node.js based CLI program, you might use Commander.js. Without parsing command line arguments by yourself, like just use a library. Libraries help programmers minimize logical errors, development times improve, but the pros, there's cons. Dependency libraries also reduce your code quality. You introduce limitations. And if bugs get introduced in your dependency, boom, it's also introduced in your project. Every programmer typically doesn't expect and study the source code of their libraries. They may provide various inputs the software can't handle. They might push the software to its limits. Maybe the software wasn't intended for whatever it is the developer is trying. Software has limitations. We have to apply several workarounds known as hacks to get things working. Developers do this all the time, but those workarounds, those hacks, those often create bugs. I always like to tell management when they talk to me, hey, you're putting a band-aid on and you're putting another band-aid on, and at some point you just have to rip the band-aid and have surgery because you broke a bone. Oh, is that a broken bone? Well, can we just no, you can't put any more tape on it. Sorry. You guys get my point. Think twice about using dependencies. Retest everything. Even after simple refactoring, retest everything. Think about how programmers initialize their software projects. Some development teams just turn on a proof of concept project into a production ready project, and they're the superheroes of the company. I've worked with a team where like they had the VP, 4 developers, and the VP was in a Slack channel like, you guys are the best thing to ever happen to this company. And when you're done with this project, you guys are gonna be heroes. People are going to be glorifying you. It's like you're going to get their kind of like, remember in Star Wars at the very end of the movie where Luke and Han and Chewie, they all get their awards or medals from Leia. It's kind of like they were praised in that way. And the crazy thing was, these guys were asked in like a 3-month period, let's take this POC, this proof of concept, and then if it works, great. If it doesn't, we'll just try something else. And thanks for the time. And then that POC turned into like, hey, we gotta make it prod ready. And then that's when other people got involved. And I always just thought to myself, if you're gonna do a refactor, retest everything. If you're gonna do any type of code change, retest. Programmers do refactoring so often that these POCs turn into production ready software systems. You need tests to ensure anything you change moving forward still works and doesn't break anything else. So truly, write tests that are meaningful and retest everything that is changed. Avoid keeping quick patches in the main code bases. No programmer can write perfect code that has no bugs. I mean, it's just not possible. There's no minor design flaws, no hidden logical issues. It's just not possible. I mean, you can be very close to that, but the code you're preparing to commit today may contain hidden bugs that you have to fix tomorrow. 3 parties will detect bugs in your code you wrote. You, testers, users, and when programmers notice a bug occurred and the user's in, they often try to solve it by applying quick patches. These quick patches are also known as hotfixes, and in some development scenarios, they work. They're the right thing to do because, hey, we are in a time crunch. We need it, like I said, going back to the Wells Fargo example. People cannot log into whatever. Make it work, and then we'll fix it long-term later. Just make sure people can log in. Okay, I bought us some time. I had a hotfix. However, we often have to write instant patches to save software products, to save their reputation, to save the company, to save a whole bunch of PR mess, right? In those scenarios, like I said, hot fixes do the job, but don't get in a habit of keeping them in. Make sure you're going back to your product owners, your management, whoever your stakeholders are, and really pushing for, hey, we need to get the long-term fix in. Otherwise, I might be on another call because the new Band-Aid we applied isn't holding up. Write clean code with a good code style guide. Every senior engineer motivates their project junior engineers to write clean code to maintain their source code quality. The clean code practices, they really help you make your code base less error prone, understandable, extendable. It's like looking at a house and somebody who has a clean, organized house versus somebody who's like, I know where everything is. And those people are always the ones who are having like everything on the floor and the ground, and it's not organized in any way, but they know where everything is. It's hard to kind of work with other people because not everybody else can think that way. Clean code practices in this regard, they really help you reduce the complexity of logical flow graph type stuff. Think of your code bases if they're not clean. Think of spaghetti code. If we're talking about like a logical flow graph, spaghetti code, things become more complex. More spaghetti, more things overlapping. More complexity makes it harder to dive in, makes it harder to change, makes it harder to test. So it's always great to write clean code, have things separate, have things follow a certain code style. And those code styles are usually established by the seniors, by the principals, by the people who are supposed to be leading this project, leading this effort. So if you're a tech lead, that's your job. If you're a junior engineer, you want to observe, you want to ask questions on what is the code style. You might be in a situation where you might have a lead who isn't doing this. That's okay. If you're the junior engineer, you can speak up and you can say, hey, what's our code style? How do we write clean code? What some things we agree on, what some things we need to talk about. And lastly, rethink your error handling strategy. All software systems do 4 generic actions: to capture inputs, process data, store information, and display return information. Every user action has an expected result. If I enter my PIN and I hit enter, I ask for $20, I'm expecting the machine to spit out $20. If I'm using Angular CLI and I want to create a new SPA, we expect the ng new command will scaffold a new app. Sometimes software programs cannot give the expected results during runtime. So in those situations, programmers have to write error handling code to give an alternative result instead of the expected result. So programmers use different approaches to handle errors. Some programmers use if-else conditions to check error codes. Meanwhile, others are using exception, catch, try catch, try-catch blocks. Unhandled errors may cause system crashes. Continuing program execution with errored input may crash your system or possess invalid information. It might do something on the hardware, might take the software to push the hardware to a certain point. So you have to make sure your error handling approach is good enough to produce a better alternative results. Instead of it breaking, you say, if this type of action occurs, I want you to be able to handle it and do this instead. Overusing try-catch like models lead to buggy, error-prone code. Due to this reason, Google's C++ style, for example, doesn't really recommend programmers to use standard exceptions at all. If you look at the Go programming language, it doesn't offer exceptions as a feature. So reducing error handling flows via default values is really a great practice to avoid unhandled errors related to system breakdowns. So I hope you enjoyed this episode. I hope you got some advice on some things that can really help write better code, because when you're working on a team project, it doesn't matter whether you're the junior, the mid-level, the senior. These are all things that a lot of people overlook. And these are all things that if you're trying to figure out how to get to the next level, if you're a beginner, you're an intermediate person, these are things you can speak up on. These are things you can talk to your team about, because you might be in a situation where no one is saying, hey, we need to do these things to reduce bugs, or hey, I kind of noticed we keep doing hot fixes but never going back. Can we talk about that? So I hope you enjoyed this episode. You guys know where to find us. Check out peopleintech.io. Check out the blog. It's coming out pretty soon. Outside of that, that's all I got for you. I'm out. Peace.